Good morning, class. Today we are going to be, this is our schedule for today's class. We'll be discussing on the third law of thermodynamics. And let me start from the third law of thermodynamics. If you are writing, bring out your pen and write the third law of thermodynamics. Are you ready? Just quickly jot it down and we could still come back to it. This law states that the entropy change of all perfect crystalline solid is zero at absolute zero temperature. This law states that the entropy change of all perfect crystalline solid is zero at absolute zero temperature. You know the entropy, which is delta S. S stands for entropy, H enthalpy, then G our Gibbs energy or free energy or available energy. Now let's go to the business of the day, the redox reaction. The redox reaction. Let me quickly give an acronym that I've always been using. You've seen it before, all right? OILRIG. OILRIG. Where's my second marker? OILRIG. And what does that OILRIG stands for? It says oxidation is loss, reduction is gain. You need to understand that reduction basically occurs at the right hand side of the cell notation. When you are starting dealing with the E.M.F of a cell, you understand this topic very well, electrochemical cells and series, which is the cathode. So therefore, you can say reduction occurs at the cathode. There you can have your cathodic rays. Cathode produce cathode ions, which are called cations, while oxidation occurs at the left hand side of the cell. You can also say oxidation occurs at the anode. The anode produces ions which are called anions. So if you are looking for the electric potential of a cell, I just say let me just divert a bit. You are going to have electric potential of that cell which was reduced minus electric potential. Remember that half cell. Sorry, let me bring my marker. You have half cell plus half cell gives you a full cell. So you are going to be having two cells. I want to get on this now. So is either you use electric potential of that which was reduced minus electric potential of that which was oxidized, or you use right hand side minus left hand side. This is your right, this is your left. I used to use mathematics to decode that. When I'm writing mathematics and I have S is equals to 5, I remember my teacher once told me that the subject is preferred to be written on the left hand side. So this is your left hand side, what you are putting here. Or you can use cathode minus anode. Now this is a cell now. We call this one schematic representation of a cell. Ag, your silver, Cu, your copper. Are we getting it now? So now you see this single slash here. They asked it in WAEC last year. They said that this single slash, what does it mean? It means phase boundary. This is Ag solid. This is Ag ion. I get now. One is a molecule, one is an ion carrying charge. Then this double slash here, when you have a schematic cell representation, this double slash here symbolizes phase boundary. Oh, sorry, I beg your pardon. It is this single slash that stands for phase boundary. Double slash stands for in the presence of a source bridge. That is the essence of the double slash. In the presence of a source bridge. It's very important. I get now. If you are drawing your voltmeter, you have your source bridge there. That is why everything is measured in volts. Then you have your single slash, which also what stands for phase boundary. Phase boundary. Remember, oxidation is loss, reduction is gain. Loss and gain of what? Of electrons. Loss and gain of electrons. I found out that students find it hard in writing an oxidized and a reduced reaction. So let me help out on that. For example, for oxidation, let me just pick. Maybe you want to write an oxidized form of copper. Copper is Cu solid state of the matter. It is optional. Then you are going to have is oxidized Cu2 plus Aq plus 2E minus. Remember, oxidation is loss. Oxidation is loss. This is the oxidized form for copper. Now, if I want to write for, let me say, reduction. Let me just use RED for red. For let's say aluminum, let me say aluminum. You have Al3 plus Aq plus 3E minus to give me my Al solid. I've always told you that anything that is carrying charge Let me cover my marker. Anything that's carrying charge is aqueous. Anything carrying charge is aqueous. So if you're writing Al3 plus, you have to put your aqueous there. I get that because electrolyte conduct electricity in the aqueous phase. This one is carrying charge. Let's make sure that we are at least able to decode something from some of these, because you still need it basically in chemistry as you proceed with. Aluminum is trivalent. All members of group 3 are trivalent. I think boron is also there, gallium, thallium, and the likes. Group 1 are univalent, sodium, potassium. Group 2, calcium, Ca2 plus, magnesium, Mg2 plus, and the likes. Now, I have a very wonderful compound that I want us to name. IUPAC. I love organic chemistry so much. Now, you want to give the IUPAC here. Remember that our rules, and you've only two basofin concession. There are rules guiding IUPAC. Now, you're looking at this compound. This compound is looking at you. How do you give the IUPAC? Remember the formula of IUPAC, International Union of Pure and Applied Chemistry. Remember the rules that says carbonyl carbon is carbon number 1. So you start from here because some students are confused. They don't know whether they'll start from here or from here. Follow the rules. There are rules. The textbook I recommended for organic chemistry, Understanding Chemistry by Godwin Ojokuku, they kind of explain some of these things meticulously. So this is carbon 1 because there's a rule that says the carbonyl carbon is CO. This is carboxylic is made up of carbonyl and hydroxyl. I get that. So the carbonyl anyone that is having CO, you start from here first of all. Even your esters to your alkanoate, COOH, start from here. So the carbonyl is carbon number 1. So that is why I'm starting from here. So this is 1, 2, 3, 4, 5, 6. X. I am seeing double bond. If you want to name this bond, you start from here. After the first bond, after the first carbon atom, single bond. After the second carbon atom, single bond. After the third carbon atom, single bond. After the fourth carbon atom, double bond. So if I'm going to name it, it's going to be X4 because the double bond is under the, so this is like hexene. And you have what? Alkanoic acid. So let's go straight up to the naming. Now there's a rule that says inorganic before organic. OH is inorganic, CH3 is organic, comprises of carbon and hydrogen. So you start with the inorganic first. I get now. And if you have multiple functional group, you follow alphabetical order. Inorganic before organic, then alphabetical order. Okay, let's start. So this is going to be 1, 2, 3. On the third carbon atom, I'm having hydroxyl. So this will be 3 hydroxy. Which other functional group again am I having? Anything apart from carbon and nitrogen is a functional group. So CH3 is methyl, is a functional group. So 3 hydroxy, and this methyl is on the what? 1, 2, 3, 4, 5. It's on the fifth carbon atom. 3 hydroxy. Oh, 5 methyl X 4 enoic acid. Straight up. 3 hydroxy, 5 methyl, 3 hydroxy, 5 methyl, X4 enoic acid. Let's look at it clinically well. 3 hydroxy, yeah, 1, 2, 3, 4, 5. 1, 2, 1, 2. I want to confirm 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Yeah. 3 hydroxy, 5 methyl, X4. It means on the fifth carbon atom is where I have my methyl. Let's take note of this. CH2. 1, 2, 3, 4, 5, 6. Yeah.